Okay, let's just get right into it. If you've been anywhere near a developer forum lately, you know the debates are literally everywhere. Open source versus proprietary cloud APIs, speed versus accuracy, and the big one, is the Hermes AI agent framework actually the Claude killer everyone says it is? Well, in this explainer, we're going to cut straight through all that Reddit hype and look at the hard, side-by-side technical benchmarks. Because listen to this number, 34%. That is a staggering 34% of enterprise AI pilots failing simply because of undocumented tool limitations. I mean, think about the sheer amount of wasted engineering hours, not to mention the thousands of dollars in misallocated infrastructure spend. That massive failure rate is exactly why we need to unpack these benchmarks today, moving way past the anecdotal success stories to see where this framework actually breaks down in production. We've got a seriously packed agenda today. We are going to quickly cover the AI agent hype, the real speed versus accuracy benchmarks, multi-agent tool limitations, the true cost of free, enterprise deployment realities, and finally, where things are heading with the road to 3.0. All right, Section 1, the AI agent hype. It is wild to think about how fast we got here. The shift from single prompt engineering to autonomous loops has been absolutely explosive. We started with that foundational React paper back in 2022, saw OpenAI add function calling in 2023, and now we're looking at Hermes 2.0 capturing a massive 34% market share of open source deployments by hitting 2.3 times faster tool execution speeds. And, now we're already gearing up for Hermes 3.0.
Now, context is key here. Hermes is, at its core, fundamentally an open source implementation of the React framework. It's designed to iteratively generate a thought, pick a tool, and observe the result, but it is heavily optimized for high-speed function calling. But as we're going to see, optimizing purely for speed introduces some pretty fascinating and honestly sometimes frustrating structural trade-offs.
Which brings us to Section 2, speed versus accuracy benchmarks. So, is Hermes really 2.4 times faster than Claude? You've definitely seen the bold claims online that it just absolutely destroys Claude on speed. But we really need to ask, does that metric hold up across all engineering workloads? Is it universally faster, or is it just a highly situational advantage? Let's dive into the actual telemetry data. Okay, so for parallel simple tool calls, the hype is absolutely real. Hermes clocks in at an incredibly impressive 0.8 seconds. Compare that to Claude's 1.9 seconds or GPT-4's 2.1 seconds. If your workload involves calling, say, 5 independent REST APIs at the exact same time, Hermes's tool-used router parallelizes this beautifully. It really is a genuine 2.4x speedup. But there's a catch. As Stanford's Dr. Sarah Chen points out, its speedup is actually pretty narrow. When you shift to complex, dependent reasoning tasks, where step B relies on the output of step A, Hermes's accuracy drops by 15%, and its latency actually spikes to 4.2 seconds. So while it processes an incredible 89 tokens per second, it really stumbles on sequential multi-step logic. Let's move into Section 3, multi-agent tool limitations. Because at the end of the day, speed doesn't matter much if the tool fails to execute, right? While Hermes handles simple REST API validations almost flawlessly, we're talking a 98.7% success rate, there is a stark drop when you throw complex multi-step OAuth 2.0 flows at it. It plummets to a 72% success rate. And honestly, the most concerning part, 12% of the time, it fails silently. No error reported back to the developer whatsoever. You just cannot afford a silent failure in a production authentication pipeline. And then we have the multi-agent orchestration side of things. If you try to scale up to a 10-agent cluster using Hermes's current broadcast communication, 82% of your execution time is entirely eaten up by overhead. Just think about that. Only 18% of the compute time is doing actual useful work. The rest, it's literally just agents talking over each other. This is a fundamental architectural limitation, and it means more agents definitely do not equal better performance. MIT's Professor Alex Thompson highlights this perfectly. Hermes shows a quadratic communication overhead. Unless you strictly keep your cluster to 5 agents or fewer, that broadcast topology creates a massive bottleneck. Every single agent you add beyond 5 slows the entire system down by another 40%. All right, Section 4, the true cost of free. We really need to address a super dangerous misconception for tech leads right now. the idea that open source naturally means free. The marketing loves to push this against proprietary cloud APIs, but the reality is way more nuanced. Just to run inference locally, you're looking at an upfront hardware cost of $1,599 for a single RTX 4090 GPU, and that doesn't even factor in your electricity, which is about $45 a month, or, far more importantly, the engineering maintenance hours. Actually, 68% of enterprises underestimate open source total cost of ownership by a factor of 3. When you actually sit down and run the numbers, factoring in, say, an $85 an hour engineer doing about 4 hours of maintenance a week, Hermes's true total cost of ownership is virtually identical to the Claude API. You're looking at $0.0028 per 1,000 tokens for Hermes versus Claude's $0.003. It's basically a wash. You don't actually see the financial benefit of open source until you cross a massive break-even scale of 800,000 tokens per day. Most mid-sized startups are just taking on infrastructure headaches for zero cost savings. So how do you avoid wasting your budget? You should follow a strict calculation framework. Calculate your daily token volume, model the true TCO, compare it to API costs, and seriously consider hybrid routing. Hybrid routing is actually a brilliant strategy here. Send your high-volume, simple parallel tasks to local Hermes deployments, but route the low-volume, complex reasoning tasks back to Claude. Moving on to Section 5, Enterprise Deployment Reality. What actually happens when you push this framework out of a local laptop prototype and into a scalable enterprise system? Well, it reveals some pretty massive gaps. Because Hermes lacks built-in middleware, developers are spending an average of 47 hours just building custom production scaffolding. Compare that to literally a single day of work, 8 hours with Claude's API. Engineering teams at companies like Stripe reported spending up to 6 full weeks building out a middleware layer just to make Hermes stable enough for basic usage. And if you're in a regulated industry like finance or healthcare, the open source flexibility comes with a brutal setup tax. Hermes has no SOC2 Type 2 certification. It's missing structured JSON logging for ELK. There's no native OAuth authentication, no built-in rate limiting, so you have to manually set up Redis for that, and it lacks Prometheus metrics exporters. For a lot of enterprise deployments, this makes it an immediate non-starter. Finally, Section 6, the road to 3.0. Now, before you completely abandon your open source strategy, the maintainers are very aware of these bottlenecks, and the framework is evolving. The highly anticipated Q2 2026 Hermes 3.0 release is actually targeting these enterprise gaps head-on. They're shifting from that messy star broadcast topology to a graph topology, which is going to dramatically reduce that communication overhead from 82% down to just 15%. Plus, they're introducing adaptive retry logic with exponential backoff to fix those OAuth failures, and even aiming for SOC2 certification with a Hermes Enterprise tier. But the true final battleground here is context window size. Right now, Claude completely dominates document processing with its 200K context window, while Hermes is stuck at 32K, which kind of makes it useless for giant legal contracts. However, industry projections show a rapidly closing gap. By 2027, we're looking at a level playing field with 1 million token context windows across all models, open source and proprietary. So, as we wrap up this explainer, I want to leave you with a question to really think about. As these technical gaps vanish, when Hermes hits that 1 million token mark and finally lands SOC 2 compliance in 2027, how is your infrastructure strategy going to adapt? Will the sheer plug-and-play convenience of proprietary cloud APIs still be worth the premium? Or will open source completely take over the enterprise? It's a massive shift, and honestly, it's something every tech lead needs to be planning for right now.